Oh, sorry. It's yeah. Oh, check it out. It's independent. And that's enough. No. I can't do it. No. So, like, okay, so should we start or see? Okay, I think we can start. So, what we will do is that we will just continue from where we stopped yesterday. We will continue from where we stopped yesterday. We want to calculate some mean bars. So we are using this formula.
और बैटरी अभी भी ना जरा
Water tire stocks. Okay. We are using this one.
देखो
Yeah, we are using these ones. We we gave some conditions yesterday that we need to make sure that our data sets have the same spatial resolution. Have the same spatial resolution. So we did it.
केबल है
Okay? We did it.
मैं तो लगा
Also, what we did is that
पता नहीं क्यों
what we did is that we had data. Okay? We had data which had the resolution of 1 point something and 0.9 0.4. Let's make this like this. We had the data which was 1 point I think 7 something.
कौन है ना
What the resolution for the model? 09 oh yeah 0.93 by what? 1.25. Okay, 1.25 is the model. And we have mirror, okay? Or the analysis. Or we can like 4 observation, which is 0.5 by 0.5. Okay? Then what we have done is we have made this one to have the same resolution as okay. So at the end, all of them are 0.5 by 0.5 degrees. Yeah, so this is what the equation of water on our regulated it. We have used by linear interpolation. We have used by linear interpolation method. If you want to know much more about this method, you can read through. You can check some content on the internet there about linear methods, interpolation method. So that's what we have used. So if you are writing a paper, maybe a certain document, you want to make your method look bigger, okay? Look threatening, you can insert this method methods, you know that you use this method, such things you can use. Okay, so basically this is what we have done. We have reviewed our data. The one which had bigger resolution. Okay? So we have just done like we have cut it into much smaller grid, smaller grid, much smaller grids. Okay, that's what we have just done. We have reviewed from bigger ones to smaller grids. So generally, we say if you are reading your data um, from higher values to low values, we say the data is has the fine resolution. You can call it fine resolution. Okay, fine resolution means you are reducing the size of the grids. But when it is bigger, you can call it coarse resolution. Okay, or band resolution, coarse resolution. Or higher resolution is the same as fine resolution. Okay, low resolution is the same as coarse resolution. So when someone says low resolution of the data, just understand that it has small grids. Okay, high resolution, small grids. It's like in the way we have the camera. Okay, those who use the old phones. Okay, if you take a photo, you will see that maybe the image was looking like not much clear. Okay, not much clear. So you can consider it like this one. These are like pixels. Okay, so nowadays we have improved phones. So like there's iPhones. If you take a photo, much more clear. Okay, much more clear. It's like high resolution. So it's like this one. It's like we are cutting the resolutions so that we can see very small things. That's what about just done on this one. Okay, so what we want to do now is we want when we are calculating in CDO, for example, this one, you can see the order the way it is. So first of all, we need to calculate subtraction. Okay? First of all, we need to subtract. We need to calculate this one. So it's like what Kel drew yesterday. It's like we have two data sets. Okay? Let me do like this. Sure. Okay. This is our model. Okay, this is our model. And we have another data. Okay, species of there. Species of there. Okay. So what we'll be doing is like we have two data sets. We have made them to have equal grids. Okay? Equal grids. So we'll be subtracting at each grid cell. Okay? We'll be subtracting at each grid cell. So for example, this grid, we'll be subtracting with this grid. This one with this the same. Okay? So that's the idea. That's the idea. We'll be subtracting at each grid cell. I hope this is clear. Okay? So after we subtract, when you view your map, that of difference, you can just imagine like it's like this. Okay? We are subtracting at each grid cell. Yeah, so that's what we'll be doing. So we already generated those two. We already generated those two. So this is like the model, the one with the concentration of micrograph. Okay? The one with micrograph. And this one is the one made up between 2010 and 2014. Okay. So in CDO, when you are subtracting two files, you are not using constant. You just use sub. Okay? Without C. Okay? You just use sub without C. So in CDO, if you want to subtract those two files from yesterday, you need to type CDO. Oh, have you already mounted your? Can you first mount and go into the folder where I have your datasets, the one we were doing yesterday, where I have your datasets. Yeah, so you need to have this file. Okay. You need to have this file. The last file we did, if you can remember it, or just recall the commands that you did and then check which last file you did. You should have this one. Okay. And you also should have this one. Mela 2010, 2014. Mela 2010 to 2014. Okay. Do you have those files? Do you have them, or I just share your mine? Do you have those files? Oh, okay. Or have you mounted the folder? You should mount to the folder where there are those files. Okay. Today I will be a little bit slow. Yeah, so we can subtract our two files. We just need to do CDO, sub, then space, then your input file, which is this one, the model, the Afri micro. Yes, this one. Yes, we should use this one. Okay. Then we subtract with this one. Okay, we subtract with this one. Okay. And then we give it name. So you can just call it bias. Okay. I hope it works. Because you can do all the things and then you find that it doesn't work. You do it? Or you can just follow this command, CDO space sub, then your in file, another in file. Oh, so this one has two in files. Okay. You have the first in file. You have the first in file, which is like mod, and the one is subtracting like odds. So here's like the one we are using, like the model, two in files. Okay, so the model and then your standard data. And then you can try it. It's working? I heard it's working. So it means mine too will work. You have given me hope. Okay, so it is subtracting. Okay, it has subtracted. Okay. Now it means we have done this. Okay. We have done this. So after doing that, it means apart from that one, so understand that in addition to that, we have learned something that not only subtraction, you even add, okay? Add, okay? Divide, okay? Multiplication. Okay, so these commands you can use. If you have two files you want to multiply, you can just use add or subtract or divide or multiply. Okay? It's slow, you can do it if you have two files. So don't say we did not learn about division, we only learn about subtraction. No. Just use the same knowledge. If you have two files you want to divide, they have the same spatial resolution, you can just divide it. Okay? You can just divide it. Two files with the same spatial resolution. You can either divide, you can either add, you can either subtract or either multiply. So that's how it works. And actually what happens is that each grid subtract the corresponding grid in that other packet. it doesn't work like this grid will subtract from this grid. No, it doesn't work like that. So it's this grid with this grid. This grid with this grid. So this grid with this grid. That's why we have to standardize our data to have the same spatial resolution. If you don't put in the same spatial resolution, then this will not work. Okay, this will not work. So if you read the papers, mostly if you read publications, okay? Now you see they are evaluating the data. Oh, okay. Yeah, so for those people who don't have the data, we just share the one we generated yesterday. We just share on the WeChat. However, when you are working on your own, it means you have to undergo all the process that we did of standardizing the data. Yes, so when you are looking on the paper, you find that they are saying we evaluated our data. First of all, we standardized to similar resolution. They talk of this one. Which one? All of them. No, just only send the one with micro, this one, and this one, and the Mela 2010-2014. So all should have be on the same page frame. Yes. Everything. So for example, maybe you have another data, okay, which is varying on pressure levels. Another one is on single level. See, so this one cannot subtract from this one because it will not match. See? It will not match water. So everything should be similar. This is single level. Spatial resolution should be the same spatial resolution. Time period should be of the same time period. Okay? 2010, 2014. Then if it's model, then your standard data should also be the same. I hope you can understand this idea.
Itu the model is more than one. For example, yes.
If the model there's what?
There is
Three or more models.
also yes.
If you have one model,
More than one.
more than one model, you want to compare with the same
Yeah,
observation. Yeah, you can just repeat the same process with the other data. You just repeat the same process with the other. Okay, so what we have done is that we have just calculated here. Okay, we have done this part. So we are remaining with this part. Okay, so this part is simply mean. So this part is just simply mean. Okay. For example, this n is number of months in that data. So we are calculating the mean for all the time period. Okay. So we have to calculate the mean all the time period from 2010 to 2014. We are just calculating the mean. This is just the mean because here we have our calculated value, and this is n, number of time steps or number of simple time steps in short. So if your data is in monthly, it means that is months. If it's in days, total number of days. If it is years, total number of years. So to do that, it's much more easier in CDO because CDO has inbuilt command for mean. Okay? Has inbuilt command for mean. So we are calculating along the time. Okay? We are calculating our mean along the time. So we use the command mean for mean called time mean. Okay? Time mean. So when you are doing the mean, you just do CDO team mean. So in that book, I send you everything is there. Everything is there. So we will calculate the mean of the data that we generated from just the following step. Okay? So we do CDO team mean. Okay? Team mean. CDO team mean. Or if you have forgotten, we can do the same we did last time, CDO minus H mean. Okay? Then it will give you all the means which are there. Okay? So you can see here we have remarked mean. I don't see team mean. Oh, this is for here. We have team mean here. So we just use that command CDO team mean. Then our input file. So our input file is the one that we just generated the written bias. Bias is just like difference between the two. So we just copy this file. We just write this one bias. You can light up and then output file name. So we are calculating the mean bias. Maybe we can just label it as mean bias, or we can just in short MB as mean bias. Then .nc. Okay, and then hit enter. Okay, so it means what we have done is I'll try to explain like in my language so that everyone can understand. So what we did is, you remember we have our data in matrix. So we calculated a difference for the first mark. Okay? We calculate the difference for the first mark at each grid point. At each grid point, the entire domain. So we have defined like this. We have first like this is the first mark. Okay? This is the first mark. This is the first mark. And these are differences. Okay? These are just differences after calculating this and this one. Then the remaining, okay, up to 2014. Okay? Up to 2014. Those are differences up to 2014. So we just want to calculate a mean for all that time period. All that time period. So I'll calculate a mean using this one. So if you do CDO team mean, it will calculate the mean. It will calculate your mean. So this is what I've just done here. CDO team mean input file that bias, then it's read bias. So after calculating, can you try to display on CDO? Oh, in GrADS, sorry. Can you try to display it in GrADS? Yeah, you can just try to open it in GrADS, display your file in GrADS. We should see how it looks like. It was a very good arrangement that we start with GrADS so that whatever we do, we should appreciate what we have done. Okay? Other than just processing and then we lose them. SDF open. We calculated the mean bias, this one. CTL info. Okay. Set display color wide C set GX out. You know, when you do these things for a long time, you can just memorize the commands because you do them now and again. C D. Okay, the name is BCA4. I will explain why the name has returned this name. Okay, C bar. Okay, can you display?
Oh, okay. Okay.
Okay, I'll give you some time to display. You can follow those commands.
Yes. Yeah, kita. No, 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 it's also
Who has a problem? Who has a problem? The display looks different. Oh, the colors. Yeah, I heard the colors are looking different. Okay, so we are using maybe different versions of blacks. We're using different versions of black, so the colors might be different. Yeah. But how about the range? The range is the same. Is the same? It's different. Ah, okay. So how did you arrange your data? Did you start with this or you started with this? Can you check? It depends. Which part did you start subtracting? If maybe you started with observation, you ended with him. You did the opposite, yeah? Can I see?
What did you for? Why are we America only SEC? Oh, methods. And yeah, isn't so? How much oh, so
We are two students are both getting one letter C. So our two students are getting one letter. So I will try to see what happens with what part of you there. There should be somewhere there is a mistake somewhere. Or maybe when you are calculating, did you use the same I sent the data in the WeChat or you used your previous? Your own, yeah? Yeah, it might either when you are calculating somewhere, you might have messed up somewhere. Either when you are calculating a constant, probably you might have messed up with something. Okay, so that in short, just in short, you can imagine you are calculating you want to check the mass between your forecast and your observed, okay, or your model and your observed. So this is what we have done. Okay, this is what we have done. So we can see that where is other values, it means your focus is overestimating those values. If you see the negatives, it means your focus is overestimating on that region. Okay, so now you can see here over central, it means our model or our focus is what is underestimating the values. Okay, if you look over this region, let me do something. Let me do set mpd set highest. I hope you know these commands. Okay. Okay. Yeah, I just wanted to put the countries. I just wanted to put the countries. Yeah, so this one is just happening like over central, it is like inflated. In some countries, it is overestimated because of what quality values. So this is what will help us at the end of the day. So if you can be able to calculate the balance, you can see the difference between the observed and the forecast, you can get such things. So CDO can do this. CDO can try to do this. Means here of calculating simply just one mean bias, an average difference. Okay? That's just an average difference between the forecast or with the observed and the model. So we have combined a lot of skills here. Okay? We have combined a lot of stuffs. For example, we have done some calculations such as the average or mean. So I will not talk of this like how to do mean in CDO. Okay? I will not talk of this one. Yeah, previously I remember when maybe we teach CDO, we will come and say how can we do mean? We type do mean. How can we do sub? Type how to do sub. I think you can take 2 weeks, maybe the entire month. You are just moving on the same thing. So from now, you should be able to know how can I calculate mean along the time. It means if you are calculating mean along the time, just do CDO, then team mean. Okay, your input data in file, then out file. So that's how we calculate the mean for long term. Okay. If you want to calculate the total, okay? If you want to calculate the totals, for example, those people who study rainfall, it might be different for those people who study temperature, and it might be different for those people who study pollutants. For example, if you have daily rainfall, okay? If you have daily rainfall, you want to move to monthly. How do we do? Those people who are from operation offices. If you observe rainfall on a station, it's daily. You want to have monthly values. What do you do? Huh? So rainfall we call it accumulative. Okay. In most places, rainfall we call it accumulative. So you do totals. You calculate totals. So from daily to monthly, you have to calculate totals. So it means you are not using the mean. Okay. If someone says can you give me monthly rainfall? Just understand it's add. Okay. You just add. I hope in most places you do like that. Yes, we do like that. Before rainfall is accumulative. So you do, however, models, okay? Models, because some people who study models, maybe they are not weather experts, okay? So what comes in their mind is just average. Everything they have to do average. So if they say, can you give me seasonal rainfall? They will just add for you. They will just get mean for you, okay? But if you talk of seasonal rainfall, it's accumulative, so it's just total. So okay, monthly rainfall is just totals. So know how to use those mathematics in CDO. So if you're moving from daily to monthly, just add. Okay, just add. you can just write sum. Okay, sum. We have some. We have time mean. How do we look for sum? If for monthly, okay, here we need the team mean. But how do we want to do sum? How do we do it? Me too, I don't know. maybe we refer to the okay, CDO minus H sum. Okay, so we have team sum. Okay, we have team sum. So apart from I, okay, apart from I, there is another command sum. But this one you use, maybe you have two files. Okay, you add them together. This one is within the file. So one is within the file where you have different maths. You want to make the total maths as one. You add within the math. So you use team sum. Okay? You use team sum. But for this add, it's when you have two different files. Add them together. The way we do it here. But what we did later after we have calculated the subtraction, we just did team mean within the file. But for additions, we use team sum. This one. We can use team sum. So it will calculate the total. So if you are doing rainfall, you are going to move from daily to monthly, team sum. Okay? Just do team sum, then you'll get your monthly totals of rainfall. It's a little bit confusing. Some not found? In your CDO is not found? Why is mine around? Can you do CDO minus H sum? It's not there. What is it saying? It's there. What is it saying? I'll check this. What do you have? What sum don't have? I will see it. Why you see it? You have? Okay. Or remove minus. Just like remove minus. Just like CDO H sum. Still not. Okay, we'll do it. I will check. I will check on your. Yes, I will check later on your. But you can try maybe just to do CDO team sum. Try to do CDO team sum, and then use that file we generated the bias. Instead of calculating the mean, just do the totals. Try to do that if it is working. For those who don't have, try to do if it is working. Team sum, just do this one. Then use the bias. It's like you're calculating total bias, not then output file. It's not working too. It's working. You don't have the command, but it's working. It's working. Okay, if it is working, it's okay. It means maybe just somewhere for checking, but the command is there. So you don't get the totals. You are moving from daily rainfall to monthly rainfall. Just do the sum, total summation. Okay, just summation. Do CDO team sum. Yeah. Oh, okay. Then that's okay. Okay. Then that's fine. Yeah. So remember, if you want to use add or sum, it's when there are two different files. Okay, you want to check their differences or you want to add them. But within the file, your data is in daily or monthly in the same file. You want to add it. All the months you want to add, you want to get the totals. You can just use sum, team sum. Okay, team sum. So I hope this one is clear. Is anyone who is lost on this one? How I have done this? Anyone who has questions is lost. It's just a matter of interpreting and understanding what is this? This is mean. Okay? Team mean along the time. This one is the difference. Okay? It's the difference. But here we use team mean because we have calculated the total. We have added and divided by the number of months. So that's why we are using summation here. The way to calculate accurately, we add all the points. Okay? And then just divide the total number of those points. That's just the basic ideas we are using. Anyone is lost there? Before I proceed. Okay, so that's how we can calculate the bias. So it is my hope that if we can be able to calculate that one, if we can, this is the same as this one. Okay, this is the same as this one. So if we can be able to calculate this one, it means we can also be able to calculate such things in CDO, such as root mean square error. Okay, such as normalized mean bias. Okay, because we all for this one, for example, we want to calculate the root mean square error. Okay, it means we have this file. Not so. We have this file, which is this one. Okay. Then we just have to square it. We have to square it. Not so. Then thereafter, we just have to calculate its mean, the mean that we have already done, and then just put a square root. We already have all those are inbuilt commands. All those are inbuilt commands. I hope you cannot be lost with such things. If you are able to calculate this one, all these things must be simple. Yes. Or we can just start from here. You can just start from there. We can just start from there. Let's try to calculate the root mean square error. Let's try it. Okay. So we said we need to square the what? The bias. So remember, we already calculated the what? The bias. So we need to square the bias. If you are able to type to plug this thing, you easily remember. But if you just want to watch, okay, you easily forget them. So let's square our bias. So we'll do CDO. To square, we said is what? If you still can remember. SQR. One time I mentioned many things, so I know maybe we can't remember everything. So we just need to square our bias. So because this was a different, so we can just write SQ. For me, I use like this so that I can be easily remembering. SQ bias dot NC. Okay, then we are done. Then what's the next? We go back to our formula. Okay, what's the next is to calculate the what? The mean. Not so. So what calculate this is the mean of all of that this again. So we need to calculate the mean. So it's just the mean of what? Of bias. Of squared bias. Okay. So we need to come back here and we do CDO. Team mean SQ. Okay, so we can write it as what? Let me write as mean square bias. Okay, dot NC. I'll write as mean square bias dot NC. Then enter is calculated. So CDO can handle big files just in second. Okay, big files in a second. If your computer has a good processor, it can help you to handle your work very well. Okay, then we have calculated the what? The mean for the what? For the squared bias. Okay, we have calculated the mean for the squared bias. Then let's go back to our formula. Let's go back to our formula. This is our formula. Then we have to do what? Square root. So we have to calculate square root on what we square. We calculated the mean. So we are just calculating the square root of that mean. Okay. So what we'll do is we'll go back to CDO. We do CDO. What do we write square root? SQR SQRT, not so. Okay, so this will be square root of what? Of the of M is this one. Okay, so we can name this one as a root mean square error dot NC. Okay, then you can hit enter. Okay, you can hit enter. So it means we have calculated our root mean square error. Does anyone know what does root mean square error mean? What does it show? Does anyone know? Does anyone know? So what is that? For example, you see here in this one, in this file, okay, we are saying the model is an estimate here, and the model is overestimating here. Yeah. So it means in those areas we should be able to detect some errors. Okay, we need to detect some errors. That is to say, if you calculate your root mean square error, if you get 0, it means the model is performing very well. It means your forecast is performing very well. Okay? If you should be from here. It's one direction. I think root mean square error is one direction. It's from 0 going to the boundaries. So if it is 0, it means your model is performing very well. Okay? If there are other values, it means the poor your forecast or your model. So that's what the root mean square error does. Okay. So let's try to first of all, not this one. We have detected some underestimation here and here. But here the values are almost close to 0 also. So it means like it's performing okay. Except this region and this region, and somehow Okay, so let's try to display our root mean square error now. After you do that one, can you try to display the root mean square error you have calculated? Try to display it. I hope no one is getting lost on the commands that we are using. So you should be able to know which command where to use. For example, square, okay? Square root, those things we can use. Now we have added up. We already did mean. We have already done some things like add. Those ones we have already done. Okay, so let's try to display. Let's try to display our data is root mean square. This one. Okay, we can try to do it. First of all, reinitialize. You delete everything. Let's just open. Okay, qctl info. Oh, it's still the same variable. Okay, this one. So set gx out shaded, set display color white, set bd set has has C. Then we have to display this one. Okay, cban. Okay, can you display? Can you display? Can you display? Yeah, so me, I'm getting something like this. I don't know what you're getting. Is it the same? So remember, where were we getting the underestimation and where were we getting overestimations? So for example, we're getting underestimation to over central and over here it was overestimation. But all of them have errors. Whether underestimation or overestimation, all are errors because one have a zero. So you can see that our values are moving from zero towards only the positive. So the higher the value, the higher the error, the bad the forecast, or the bad the model is doing. So you can see over here, it means yet not recording well, too much again central, central recording well back. When it goes to zero, down to zero, it means everything is good. So in bigger area, everything is good. It means we have used what? We have used the root mean square. We have used this equation. Okay, so sometimes in the papers, if you look at them, they are very complex. But in CDO, they are much more easy. It's just a matter of seconds. A matter of seconds, you can process your data, write a paper, finished. Okay, evaluation of this model against this model, performance of this model against this model over this region. So you can do such paper much more easy. Thank you. So those are the CDO will help you. If you go to Python, if you go to GrADS, if you go to NCL, to come to reach that one for the first time, it's not easy. You have to struggle. But in CDO, within a day, you can master everything. So as you go along when you're doing research, you will learn many softwares. I think I said it when I was studying that. Here we learn many softwares, but there are some softwares still stand. Okay, they still stand. Like you still go back to them. When you are lost, you are in a hurry, you can do your stuffs with the CDO. You just type the commands, you punch this, that. Just understand the mathematics. That I use this, it will give me this. I use this, it will give me this. Okay? I will not do this one. This one you can just take a photo, you can practice by yourself. So you can see this one have a constant here. Okay? on top we have constant. So it means you can imagine like we are subtracting the model. We are subtracting model and offset. Down there we are adding. So this will not use sum. This one will use add because they are two files different. And then you calculate ME. Okay, you calculate ME. After calculating ME, we have just it is like 1 over n. Then that's something there. But later on we are multiplying by what? 2. We are using a constant, we are multiplying. So when you are in CDO, it means you are using what? Mar what? Yes, Mar C. So always understand which command where should I use. Yes, so it means in this one you will use Mar C because we find the after we calculate our mean over here, you just multiply the constant in that part. Then you are done. So this one, when you are doing with CDO, for example, the way we have done here, what we have done is you can imagine like this map, you are trying to get in smaller grids, okay? In smaller grids. And we have the data of each grid point. The same I was explaining here. We are data at each grid point. So we are calculating at each grid point, covering the entire study. Covering the entire at each grid point. That's what we are doing with CDO. So understand that your data you have has maybe a subscript of k which represents a grid. It is at each grid point. It is at each grid point. So CDO will calculate at each grid point, covering the entire domain. So it will do the mathematics. That mathematics we are doing here, this mathematics we are doing here, is working at each grid point to calculate. To go to another grid point to calculate until it is finished. That's what it is doing. So we are calculating at each grid point. I hope we are together. Seems some others. Can you understand the idea? This calculation we are doing, we have done at each grid point. This data is graded. Then after calculating, we have just explained how it is expansion. That's what I've done. I hope it is clear there. So by doing this, by doing this, you can do a lot of mathematics. You can do the rest of the mathematics. Since we have done this one, then this one will be able to open up for the rest of mathematics. For the rest of the evaluations and do using there's 2. You can do the rest. I hope it is clear. Do we need a break? Do we need a break? Okay. Yeah, we can go for a break first. Later on, we will do some correlations. Okay, we'll use the same data. Yeah, we have to perform some statistics. Yeah, I think we can have a short break. Yeah, questions you can ask me. It's all right. Yeah. Should we proceed? Okay.
Yeah, one final point. Yeah.
Yeah. So when you are sometimes when you have some time, I know most of us we are not doing research. We are not yet doing research, but when you have some time, you can be practicing on your data. You can be practicing on your data. For example, when you be doing your when you be doing your maybe presentations defense, okay, when you be doing your research defense, okay, you are working with a model data. One of the common questions they will maybe ask you is, do you think the data you are using is good? Okay, they will ask you such things. Do you think your data you are using is it good or not? So this is the process to verify if your data is good or not. Okay, then you can tell like, okay, my data, for example, is not good over this region, and it's not good over this region because we are having some bigger errors over those areas. So such are the process. But when we start doing research, we will come back to this thing. Yes. It's when now you'll be thinking, okay, so that thing was very important. But as of now, just grasp everything. Just take everything. It will be very important later. So assuming you make you can imagine you make an analysis. Okay, you issue a forecast like you have made a forecast, you did verify your data that it's good or not, and you are saying, okay, so tomorrow it will rain. Okay, tomorrow it will rain, but your data performs like this. You just get data somewhere. It looks over this. Okay, over this region, if you had tell them that it will rain by 5 millimeters, actually it will not be 5 millimeters. Okay, maybe it will be much low. Maybe it will even be zero. Because this model is overestimating over this. There's some errors. But over this figure is underestimating. If you talk to them 1 millimeter, maybe it will be 5 millimeters. You see? Yeah. So now we want to see the correlation. How about the pattern? If we correlate, Are they the same or not? Okay, so that's what we want to do. So let's go back to CDO. So in CDO, there are a few kinds of correlation. If you open that book, I think you will find it. There are some correlations. How we compute correlation might be different. So I was filling up this map. It becomes much more difficult. Okay, so this is our model and this is our observer. Yeah, it's like there are two people who want to compare them. So these are our two data sets. Now we want to correlate them. When you are doing correlation, you can either do time correlation. Okay, time correlation. So in this time correlation, it's like you have data starting from here. Okay, maybe it's moving like this. Okay, we can label it as time or x. Okay, and here are values. Okay, we can label them as y. So this is the model, and we want to put another data. Okay, you can imagine we want to put another data here. We want to check, is it behaving in the same way? Okay, is it behaving in the same way to our another data? Are they moving in the same way? Or maybe if this one is moving up, this one is moving down, like this. Is it moving like this? That's what we just want to check. We just want to check. This is along the time. Okay? And there is another correlation where you can correlate this one. You correlate all the box. Okay? Just all the box you correlate. Are they correlating or not? So that one we call field correlation. Field correlation. This one for time, we call time correlation or team correlation. So in CDO, if we do time correlation, it means this grid will correlate with this grid. This grid with this grid. Okay? This grid will correlate with this. So the same conditions. Make sure all your data has the same spatial resolution on the same time, same level. They should all be the same. If one is on single level, the other one should be a single level. Okay? One can either be at 850, and this one can be at maybe 700 hectopascal. Okay? No problem. As long as it's single level. Okay? Single level, no problem. I hope it is clear. Because some people can do correlation between rainfall and 850 winds. Rainfall doesn't happen on 850. It's on the surface. But we can still correlate with the winds up. But they should be single level. One should not vary in the levels. If it's varying the levels, CDO will reduce. Okay? So let's try to do in CDO. So in CDO to do correlation, first of all, we can do like CDO. You can check. I'm sorry, some computers are failing to check. So you can just do core. Okay, type core. It doesn't give the command. I think it's single R. Says what? I type CBD. Okay, so you can see here, some of them I don't know. I didn't memorize the entire book. What I know with theory correlation and time correlation. So this vector correlation, I don't know this one. You can read, there's more explanations in that book. So we just use, most of them this time correlation. We'll try this time correlation. If you have something that needs to use fluid correlation, You can try to use field correlation, but I don't know what will be the interpretation. Maybe we can just get a single value. We use field correlation. We'll correct all the grid box and just get a single value. But in terms of time correlation, we'll correlate along the time at each grid point. At each grid point, the way we did with root mean square error and the rest. Okay? So let's do the correlation. So we'll correlate our observe, we'll correlate our model and the observe. Okay? Our model and the observe. So we just do time correlation. You do CDO team core. This command, CDO team core. Okay? And then our input file. Okay? So our input file is the one that those files we use to calculate bias. The ones we use to calculate bias. Those two files. So it is what and what? Africons. This one? What's the name? Oh, Afri. Yeah, this one. Okay. And then with Mela. This one. Okay. Then we can call this one as what? Correlation. Okay. You can just type like that one .nc. So this will be correlation. You can check in the book which correlation is being used because we have Pearson correlation. We have so many correlations. So you will verify in the book which correlation is using. I think it's Pearson correlation. So then you can do enter. Okay? You can do enter. So you can see that it has processed our values. So if you do CDO S info correlation, you check the information, you see it has what? One time step. Okay? It has one time step. It means it has calculated correlation for all the time at each grid point and install that value. So this is the correlation value. So if you are not good in programming like me, if you're not good in programming like me, maybe you don't need code MATLAB to compute correlation. You don't need to go to Python to compute your correlations. You're using such kind of data. You can do it in CDO, then we'll do it for you within the seconds. Okay? The problem is that with this kind of work that you don't know what is happening inside. You are just putting the commands, it does by itself. Because when you are using some softwares like MATLAB, you have to type those equations. Okay? The equation for correlation, Pearson correlation, you have to type the entire equation. Whilst here you just you type your commands, understand the equation, you put it in your methodology on your paper. So let's try to display the correlation. Let's try to display the correlation. Actually, correlation, what's the range for correlation? The range for correlation is what? Okay, yeah. So for bias, okay. For bias, we said maybe we can say from minus to positive, okay. But for mean square error, we said from 0 to positive numbers. Okay? But now, this for correlation, we have limited values, not so. So it's just between -1 and what? 1. So if you can get your correlation and then you find 2, it means something is wrong. I remember one time when I was bachelor, so we went, when people make presentations, we went to attend one of the presentations. A student was defending It's like you present everything and then it says, okay, so I found correlation here and I found the correlation was true. Here it was one. So it's like he didn't know what I was doing. So sometimes again you can learn, you can punch your things, but and again, understanding to interpret those things very well. Because you are just using the commands. You find the vision, you'll be like, oh okay, it's fine, I'm okay. But you can't exceed one correlation. So you have to be very careful when you are using such things. Understanding the meaning part of it, the interpretation part of it. Okay, so let's try to display our correlation. We have done mean bias. We have done root mean square error. Let's try to do correlation. So correlation is just an inbuilt command. It's different from those other things you have to do this and that. So let's try to display. Reinit SDF open SDF open have it here. QCTR info set the what? Oh yeah. So we have calculated our correlation. It is saying it is from minus 0.8 to 0.8. And the interval is 2. Okay. So that's how to appear on our curve. It will go from minus 0.8 to 0.8. So it is within our range of minus 1 and what? And 1. But we are finding something like 1 point something, whatever it means like. I think CDO is cheating us. So on that one we are okay. It means you can assure yourself to say, okay, my results are true. Okay? So here minus 0.8 to 0.8 and the interval is 2. If we see it in our graph, it will look like this. Oh, I did the contours. Let's use shaded graphic. So you know like GrADS by default it display contours. That is by default. So we need to set to shaded. So set GX out shaded. Okay, then you create see and then display again. Okay, yeah, so then we can put a C bar. Okay, C bar, yeah. So on our cover we will run between this one and this one. It's a interval. So it means on our cover, when we look at our cover, the range is 0.2. Okay, each is 0.2. The range of each one is 0.2. That's what is happening with this one. So this is how the correlation look like. Okay, so it means over this region the correlation is very but here correlation will by over this region correlation. Then you can start doing your research now to start reasoning why needs more quality, why is linear to quality, why. So if you're able to answer such questions, means you are trying to do your research now at the beginning of the research. Of course, you can play around with your GrADS later to make such graphics so much more clear than this. So this is the correlation. So it means if you have written so many equations, okay, you have going, okay, You have three data. You have to create and now one. All of them have done them in what? In CDO. Okay? All of them have done them in CDO. Anyone with a question relation this part? I will temporarily stop here to wait for the question. I think we've done a lot of commands. I hope you can still remember that. If you want to calculate things like percentage change, okay? For example, we want to calculate percentage change between or if you want to calculate the ratio, you want to calculate the ratio between observed, here's the model, percentage ratio, model, and observed. Okay? We just want to get the percentage rate of each one. You can see where this sampling in what is your. What it means now you just use what? Not so. You just divide this model and the observed. And then later on you multiply by what? A constant. Wow, see. So you need to be able to manipulate such things. Based on our previous tasks we have done, should be able to manipulate such things. That is, for example, want to find percentage ratio. That's a ratio. We have to divide out in model and observe. Okay? Multiply by 100. Which means in CDO, it's just like CDO. CDO, then what? CDO, then what? We want to do it. Divide. Okay? We have to divide. Then we have model as your one. Dot LC. And then or okay. Dot LC. You get to file here X. Okay? Then that file. Later on you can just do CDO. Mar C. Okay? Mar C, comma. You multiply by 100. Okay? Then your in file X. Okay? Then your out file xx.nc. So such things should be able to manipulate based on what we have learned. Based on what we have learned previous. They should be a little bit straightforward. Okay, anyone with a question issue this part? There are so many commands in we can't do them all. We can spend 1 month, 2 months if we go command by command. It's just 2 months. But when you read them, you'll be able to know, okay, I have to do this. I just type this command because it's straightforward. They have written straightforward. Command in file, out file. Maybe just command in file. Maybe command you have to have 2 in file. Okay? For example, if you are doing subtraction, you should have 2 in files. Yeah, so such things you should be able to manipulate them. Anyone with a question? How many minutes I'm still with you? 20 minutes? Hmm? 6:20. Forward? Yeah. There are some easy issues. I think what I just do. Let okay. Yeah, first, how can we do some basic statistics in CDO? We can do reach that far, and that's my So this correlation, maybe you can correlate between it and rainfall. You can correlate what do I call it? Rainfall and do it. Just we will there put that on the same resolution. However, there are some limitations to this. There are some limitations to this. You cannot do. I'll try to check if there is a way. I'll try to check if there is a way. So sometimes you can imagine, okay? You can imagine you want to see how sea surface temperatures are influencing rainfall over time. Okay? How sea surface temperatures are influencing rainfall over China here. Okay? So sea surface temperatures will be on the wings. Those will be sea surface temperatures. But rainfall is on the land. So these two things are not on the same place. You see? I was expecting maybe I'll get such things. So those things are not on the same place. So CDO will have some problems to do such things. Because their area coverage is not the same. It will be difficult to match that wrong because your system percentages and the alternate but rainfall is on there. So some of these things maybe CDO I've not yet seen how to do it in CDO. I'll try also to check, but CDO can perform it in such a way because there are different places, so you cannot correct at which really point. Yeah. So some softwares can do that. That's why sometimes we go to another software, we go to another one. One software cannot do, you jump to another one. Yeah. So there will be some limitations in some softwares, but GrADS can correlate that way. GrADS can correlate that way. There is also another way. Maybe you correlate maybe just a point, okay? You correlate the point. Maybe that's your target. Maybe that's your target, maybe you're correct on the Pacific Ocean. Okay, you're trying to check impact of S or El Nino on your info or drought, what. Maybe there's like a small region here you want to check. Your data is MCS, okay? In Excel. So maybe CDO cannot do good such things. Don't correct this one and the entire region with one point. Maybe CDO can be good at things. So CDO will be limited much be correcting for the two data sets at the same assembly. If I find a way action, I will text in the group. Oh, I discovered a way how we can do that. But if you check it in the manual book, I think you will not find it. Yeah, so there are also some limitations to the some mathematics that you can do. So that's why some software come into so okay. I think for calculations, I will stop here. Then we'll do some things on how we can set some attributes in the files, in NetCDO files. But can we all be able to display it? Can you be able to go there? Anyone who has a problem? Anyone with a problem? No one. Okay, so I will go a little bit backwards. No, Yeah, here. Let me try to zoom it. This file where I've written set axis. So sometimes, okay, don't mix this one with the statics we're calculating. This is different one. This is different one. Last time I split because of limited times. Sometimes you download files from internet, your data. Okay? Maybe they don't have time. Okay? They don't have time. They need to see their files. You'll be finding such things, especially CMAP data. They don't have time. So you can set your own time. Okay? You can set your own time in that NetCDF file. Maybe you have downloaded your data, then it starts from 19, maybe 1991. So you can set your own time if it doesn't have time. Okay? You can set your time using this command. Set T axis. So T is time. Time axis. So the T is just the starting point. And the X is the interval. Like maybe your data is dated. It means if you put set T axis 1991 01 like that one day, it means your file will be skipping by 1 day. In the time axis, will be skipping by 1 day. 1 day. If it is monthly, we just put month here. If it is days, just like this, you put days. Then your in file, then output file. So in case you find a situation where you don't have your data doesn't have time change or time axis, you can input the time axis like this. You can put the time axis like this. I didn't have this data. I need to prepare. Next time, maybe I'll ask some time. We can just have a quick practice on this one. How to set the time axis. The time axis on your data. Generally, it is not much common. Not much common. Most of the data are already set. But in case you find such things, especially those who are working with this map data, big models. So you can set your own time. Maybe we can try with one of the data. Let me see. Let me try one of the data like the mailer CDO. Let's first check its information. Info. Okay, so I'm talking of this. You can see this is the time axis. It starts from here up to here, and you'll be finding some data sets maybe here. The way they load their files, the year is not changing. Maybe they made some mistakes. The year is not changing. Maybe it's just same year throughout. So you can just rewrite. You can just rewrite using such commands. Using this command, you can write your files using this command there. The time axis. Yeah, all this we already did them. Remap bill we already did them. The regrading we already did them. Those things. Yeah, so this set calendar standard we already did all those things. This was the only thing that we did not do. Maybe let's try to do one. We just destroy one file. I hope it works. So we said CDO set T axis. CDO set T axis, and then we have comma So can we assume that our data is starting from 2025? Okay. Can we assume that our data is starting from 2025? So we just write like this one. We can put it here. There is a comma. No space. Okay, so it is monthly. So we assume that it started from 2025. We can destroy this here. We can put it 2025. Okay. And then let's put this mailer. Oh no, interval. There is a comma. Okay, so for interval, you can just put one. You can just put month or 1 month, just like this. Means our data was monthly. Okay, so you can just put 1 month, and then we can try to put mailer. What should we give it? We'll just give it any fff.nc. We will see. Maybe there is no this comma. We will see if it works. Okay, so it has processed the values. Can you try yours if it is working? So if you do CDO s info ff, okay, so you can see our data is starting from what? 2025, not so. So it's 2025 all the way up what? 2029. So it's like we have destroyed the original access in that data. We have rewritten by ourselves. So we have made it to start from 2025 all the way up to what? 20. So you give someone this data, you say, okay, I have data here. Can you analyze my data? Someone will just open this data. Oh, your data is already ahead. You did a forecast. You just wrote this. You just wrote this inside the data. You just modified the time axis. So if you find the data in short that doesn't have the time axis, you can modify it. You are rewriting the file by yourself. It's the attributes by yourself inside the data. So you can see what CDO does. CDO, we can change the variable inside it. Okay. We can change the variable inside it. We can even modify the time axis. Okay. If you even upload this data on internet, say, okay, I made a forecast. Somehow it say, okay. So you made the forecast. It's not, you just modify the things inside. So that's the command. Oh, okay. So, where is the command? This one, set t-axis. It ends here all the way up to here, 1 month. Or you can just use this ppt. You can use this command. You can either put minus or just remove minus. CDO set t-axis. Then your t is your starting year, which is this one from here up to here. And then you have interval here, 1 day. But it's better you use the CDO one, the one we used. So for CDO is this start from here. So you can change the time. Or if you don't have the time, you can use you can input your own time axis in the command. Yes. So assuming I want to calculate the long-term mean, okay? The long-term mean of my data formula. I want to calculate the long-term mean, the mean for all the years. What do? CDO. CDO what? I just want to calculate the average for all the years. Team mean, not so. Yes. Team mean. Okay. Let me put Mela. Okay. Then I will write Mela. Okay, let me just write mean Mela.nc. Okay. So I have calculated the mean. If your data is very big and your processor is very slow, it will be taking some time calculating the percentage, like what is doing. But this is very fast, so it is doing very fast. So let me do, I'm so fast. Let me do sinfo CDO sinfo and then check. It has written what? 2012 06 16. Okay, so there is one time step. It means I've calculated the mean of my data. So in case you want to display the mean of your data for all the years, you can do the same. If you want to display the totals, that's what I already said. You just do CDO what? Team sum. Yes, it's no longer add. Now it will be team sum. Okay, so you do CDO team sum. So those are some of the just basic mathematics that you can just see them in that manual book, and then you can use them. So for rainfall, for example, rainfall, you just do CDO team sum. If this was rainfall, you just do CDO team sum. Okay, CDO team sum. Team sum, then Mela. Oh no, it's only this one which is coming. Yeah, this one. Then with this one can be sum Mela. Yeah, so it means these are the total values. Those are just total values. I've just added them. Instead of calculating the mean, I've now added them. So in this way, this is how you can calculate the total rainfall. You do like that. From daily, you move to monthly. From monthly, you do go to yearly. You do accumulative again to yearly. We don't do mean. You can only mean maybe along the years. It's when you can mean rainfall. But moving from daily to monthly to yearly is accumulative. Yeah, so those basic mathematics, I think you can just see them. Yeah, you can just look at them. Okay, the command is like this. Then you can do CDO sum, CDO no, CDO add, CDO divide, CDO square root, CDO square. Such things, I think they are much more easier when you look at it.